plus, we all the standard was just one series. And this is the race. Always it rings for 2 times. We're back and of course. Scale should have some fruits. Alright, after this we can check our compass. Do you range with your Pankaku? No, it's good enough. Just make sure there is no other compounds. Because later you only want to see signal from this compound, right? You rinse it to wash away other compounds. That's good enough.
Slightly, I'm just like curious if the methanol still in there that makes
Methanol is okay. Methanol is like the solvents.
so it won't.
It will not contaminate your signal. Like it's kind of like small molecule, like acetyl nitrite.
Yeah.
Also like acetate, our AB mix cells has acetate and ammonia. So it should be fine.
And you pack how much?
More than 200 microliter is getting out. And get away the bubbles. Then put the adapter. Then this skip.
Wait, so you remove the little part, you mean that probably.
Yes, adapter.
First, this can go from.
It's good. Yeah, it's connected.
You just pull it out.
Yes. Later I'll let you operate, so you are update. So you push it forward a little bit too, because this tube is kind of empty, so we just fill it a little bit to see fine.
You manually push it yes with that black thing.
Yes. So just push the liquid that goes through the tube, then inject inside. Okay, after this we can take off the gloves.
How many software do you know?
This guy here. Well, we have this one for the accuracy machine, and then we have the analysis software, All Star. But that's okay.
But to run and everything to us, one for us, that's it.
You know what? Sometimes because our method has a lot of transition, so not too many data points, right? So it's always like one peak, because Mark only has like 1 or 2 compounds, so the peak is split here. Like this 3.3 is one peak, so they have one peak here. Like we know 3.0 is glutamate. Maybe that's 3.3 may be glutamate.
I was thinking I kind of look similar.
Yeah, it might be glutamate. I'll fix them all. Need glutamate. By default, we run LCMS, which is this one. So for magnitude, you will have to deactivate this one.
Well, can you go again? Like, okay, not the software system, but I'm not sure where to go.
It's like later I'll let you operate. Ideally, normally in the acquire session, right? You go to the hardware configuration. Hardware, yeah, double click it. Then you can see some like check there. So normally we run LCMS, which go LC to MS. But right now for manual tuning, we only need MS. That's why we deactivate LCMS and select mass spec only. And activate profile.
The brain is being activated.
Yes.
Okay.
So right now mass spec is on. You hear the sound?
Which sound?
There's how many
Because you want
sound.
the additional.
And something important right now, because by default, you should select the syringe pump method, because by default the syringe is not for this one. Select the syringe pump and edit. You can see the diameter, right? You see that?
Oh, I don't want that.
Yeah, our syringe is the 500 microliter one.
Oh, you have to select the right one.
Yeah, or else the speed will different because depends on the diameter, you know. So we select the 500 microliter one. It's 3.26. This one. And
Nice.
okay. And also the speed matters. Because at the beginning we wanted the syringe to push it to the mass lag, right? We don't want to wait for too long times. So probably I'll try maybe campus. I forget. I haven't done this for a long time. So we just select K at the beginning. Maybe 20 is also fine. And then we need to know the mass of our compounds. I build like a PPT fire. And for this one, the molecular weight is 160. So we can set the range from, for example, 110 to 220. So keep it in the middle.
Yeah.
This is a mass,
150. Alright.
Okay. Then we can start the syringe. Then it start, right? Click acquire. Oh, what's that? Oh, start. Then click start. Oh, sorry, there is one more thing we need to do. Before we do that, there is one more thing. We need to set the parameters. Stop it. Okay. You can see there is a lot of parameters like coating gas, iron spray, temperature, everything there. It's like in our LC method, we also have the same parameters. You should use this parameter all the time. Like in this case, the magnitude one will be the same with our LCMS. Okay, you can see, for example, this is 25. 3800. Temperature is 50. One is 40, I guess. One is 50, one is 40. And one is 40. Yes, okay. So the parameter is done. And you got it. Everything's good, right? You wanna stop? Let me stop. Okay. Okay, so then we start the syringe again. And we start the acquire again. You can see it jumps everywhere. It's because actually this is the liquid in the tube before our syringe. And one more thing you can see, right now seems no signal, right? It could be possible.
How do you know that? No signal.
Ideally, there should be one peak at 160. Should be very high. So one possibility is maybe right now it's good enough. Let's stop it. For example, like the molecular weight. It should be 160 zero, right? And the potting mode should be one more because one hydrogen will attach to it. So we're looking for like 161 in the potting mode. But we do not say it here. So possibly it might be in the negative. So let's try negative. So normally we try positive, negative. Let's go. If it's negative, ideally it should be 159, like a one mass less. Let's see. We see something here. So this is good. So which means this compound can be found in the negative mode instead of positive one. And there is one more thing I would recommend you to do that. Isabella, remember this MC? Did you use this one?
I don't remember that.
Okay, I guess not.
So you click it and I
Yeah.
know it.
I was about to explain to you because this one is very important. Like before they do not use this button. That's why they have to prepare very high concentration so they can make it. This one actually, you can see this spectrum jumps all the time, right? It's like do it again and again. This will actually sum them together. So it will average the noise, make it your signal stronger. So remember, this MC is super important. Yeah. Okay, so let's do it again. And this time I'm going to take a picture. You pay attention to the value, it will increase. You can see twice, you can see a lot of peaks, right? But this one is actually the only one. Okay. Well, I'll wait for a while. You can see the value is increasing. There is a bubble, I guess. Oh, what's going on there?
Oh no.
Let me stop. Ideally, it should be kind of flat. This looks good. I guess there are some bubbles sometimes, that's why it jumps down. Should be kind of consistent. So it looks alright, right? We can stop here.
That's yeah.
Great, fun.
Okay. Then I will take an image for this one because keep the record. In the future, if you don't know or not sure, you can come back, make a screenshot. And this is the negative. Q1. You can see it's like a 158.9, right? 8. Something like this. Just keep a record. And for positive, we do not find a signal, but we can still write something. Let's double check it. Is the border saying up? It's still right. So we'll keep it. Sometimes if signal is too weak, we can increase the concentration.
How do we know why so weak?
You need, for example, no peak. Like if both positive and negative have no signal, before you give up, try a higher concentration. Like this one, you can say compare with the negative, no obvious tip, right? So we just stop it here.
So it takes a small wave and the look away. That is not right there, then it's not right.
Yeah. It can be, for example, we have like ammonia. Sometimes ammonia will also attach to it. So there's some mass plus like 14 or something. And also there are fragments. So sometimes they have other fragments. Like, but it's kind of complicated there.
Yeah. That's next lesson.
Yeah. So like positive, we write no there, no signal. Okay. So right now we have the negative Q1, right? We move on to Q3. I think better knows you have Q1, Q3. You can find the compound. But when you're going to know that one day, don't worry. So one thing important is you pay attention to this scan type. Because it's Q1, so I did not change anything, but she personally should pay attention to change it back. So we do the Q1 scan first. After that, so we are going to do the product iron. But remember this, it's important. Product iron.
Iron.
Yes. It's like you have the Q1, right? You're going to bombard the molecule, make it fragments. So you know what is the fragments. Normally in our method we call it transition because there is a lot of fragments. We normally select the strongest one. But actually there is a lot of different fragments. Yes. Okay. You should add the mass here. Product of something, right? Because we write the 15849, so we write the same value. I think Bella still remember this.
I do remember.
Okay, perfect. 156.8.9. If you do not input this value, you are going to have nothing. Because they're kind of like tandem, right? That's called tandem?
Yeah.
Yeah, connect to each other.
It's a good word.
Okay. Then we also scan the range. Normally we started from 20 maybe to like 160. So slightly more than that. Okay. And there is one thing maybe Mark does not do that. First, of course, you should select the negative. Make sure the right polarity. Something Mark might not do is we need to go to the edit ramp. Like I guess Mark will just select the highest one then it's done. Here we're going to scan it. It's called clear energy. We are scanning clear energy.
Oh yeah, we did.
Yeah, it's like from the lowest one to the highest one. Maybe 5 is good. Let's see what's going on. So in this case, just scan it and combine them to make one picture. Let me show you. Here it is. So remember to select this one, MCA, or else it will not connect each other. And start your game. And wait for 5 seconds maybe. 1, 2, 3, 4, 5. Let's go. So as the beginning, not a very strong signal, right? We see something, but not strong enough. Okay, you can see it's getting accumulated. So 41.2 seems a good one, right? And then gradually we have other transitions. 59 is getting better. All right. So you can see this one is actually the Q1. So, and all these peaks are actually the fragments.
What is fragment?
I give you an example like the. Are you familiar with the structure of MED? Any structure you are familiar with?
Well, you could say
For example, MED is made of like a kilometer ring and also ribose ring.
now.
So when you use iron adhesives,
You just break it.
break it. So you are seeing kilometer fragments and the ribose fragments. So you needed this mass to guess the structure. Maybe that's why Bella is a little confused about the Lysen method, right?
Yeah.
We need to know the information.
Yeah.
Okay.
Base.
Yeah. So right now you can see because sometimes they cannot be completely fragmented. So you still see this one signal, right? But you also see some signal like that. So we can take a look here. It goes to 1.9.1. But I would say because it's kind of in the side, right? I prefer the center. So I'm still going to stick to 1.849, the center. Okay, not just the strongest one. Sometimes, shift a little bit. So center is better. Okay. So first, let's take a picture again. We call it Q3 ramp. And Q1 is still 158.9, right? And the Q3, we have several Q3 value. You don't have to go all of them, but the 3 is okay. Like 1 is 41.0, right? This actually be a weak one, but we still keep it here. And there is 159, maybe 0.1. Even though high is 3.0, right? I would go 9.1. This might be our star. We're probably going to use this one because obvious stronger here, right? And the Y is 115. 115. I think the 3 is quite enough. No more than 3. It's a waste of time. Ideally, you can also go with 87 or 30, 43, right? But not that necessary.
So, I didn't all the Q3.
So, like a 5 would equal Q1 or not?
I see. So again,
Like all the Q3 pick when they combine become Q1, right?
Not exactly, because it's kind of complicated. Ideally, but sometimes they bombard with each other, you know. So like
They combine without separate.
sometimes, yeah, it's so not exactly. Yeah, kind of, you can understand it that way, I think.
Like, for example, look this pen. Like when you rack it, but yeah, and then so it should be smaller than the. Oh,
that's
good. That's true. So why they subject that even line higher then?
Oh, you mean than this one?
That's Q1, right?
Yes.
But that
Imagine the energy of your electrons getting stronger, the more fragments you're going to have. So as one energy, this peak will disappear because they are all fragments. So no Q1 signal at all. When you increase it higher.
yeah, okay.
You got this?
Well, I thought my question was this, okay?
Yeah, it's okay. Okay, gradually you understand this. All right. So we move to the next one. So right now we are going to do the, and also you can play with those parameters. Yes, and Bera maybe Mark 2 or something, right? Hope you can remember that. Because the signal is good, so I do not play too much.
Yeah, the cohesion energy, I feel like there was something where you kind of play with that. How would you know to play with that?
You mean clear energy?
Yeah.
Later we'll find out.
Okay.
Yeah, so because first we decided what is Q1.
Yeah.
Then second step, decide what is the Q3 we're going to work with. And then clear energy and declass the potential.
Okay.
Yes. Now let's go to the step. We use the MRM. So this means the combined Q1 and Q3. Oh, yes. Then we have the Q1, 158.9. And the Q3 is 41. And the dual is 200, something like that. And there will be several. 9, 59.1, 9, 9, 11. So in this case, we can do 3 transitions at a time. I guess Mark may also not go to about this.
No, I think we did do this.
Okay, that's what I want.
This is like where we like more started rather than like going through this in between steps because we looked up on the one website that shows you the experimental level predicted, and so we just put in those values.
You use that.
We found it through that.
Oh, that's a good idea.
Yeah.
So actually, you did not even use the value based on
No, he went through it and is like, this is what you can do, but like, since we already had the values, we
Okay.
found them on the website,
Okay.
and we just went here and actually hit it.
Okay, sounds good. Then we do the ramp again. The ramp means scan actually.
Yeah.
So let's scan the clean energy still. I think 2.5 maybe. And we just start it. Normally when you start, it can be some like warm up time. So after normally 5 seconds, I'll click the start. You are going to show the peak. Yes, we just also take a picture. So in the future, we don't have to redo it. Right here. We call it CE and the DP ramp. And also we can write down here. Normally I have a sheet called the magnitude. All the magnitude method will be here. Like this is the OXO. Oh, too big. All right. Like this. I'm gonna do it later. So first, this is the 41, right? You can show the CE here. The energy is recommended to be 15.7. So you just write it down here. And 3. This tradition. And you go to the next one. This one is much less. So 18.83. And the last one, even smaller. 13.64. Okay. Now we have the clear energy. So Tuan, do you know what is clear energy?
We'll make it by lab. Energy.
No. It's like you bombard the molecule with some energy, right? Like maybe hydrogen iron. So this is the energy of the hydrogen iron, how quick it is. So you just scan it. So for example, at this energy, minus 13, you see more fragments of this value. For example, this value is like 150. The mass is 150. So at this energy, you will see more fragments from 115. And for different fragments, like 41, right? The energy is minus 50, which means it requires more energy. You have these fragments. So like some bond is high, so you need more energy to break it. Some bond is loose, you need less energy to lose it. And it does not mean the more power, the better. Because sometimes
better.
yes.
Love it.
Okay, so we got this right.
I know.
Okay. Then
It's a pretty.
Then the last parameter is the decluster potential. Does Bella know the meaning of the decluster potential?
Beach clustering potential.
Uh-huh.
I put in just to get through the calibration I need to do.
Sorry, Tana, it's not a test. I just want to make sure you guys understand it.
It was. You just be thinking.
I don't remember.
It's like this. For example, there is a molecule. You bombard it to make a fragment, right? But they all gather together. That's why it's clustered. In another way, they were going to get clusters. So you can separate the Q1, Q3 or different ramp.
Like calibration.
Like also we should say like step. We'll ramp it from 0 to minus 70 or 300 and do the scan it. And let's start. I always like wait for 5 seconds. 1, 2, 3, 4, 5. Okay. Then let's go. Bye.
Are we? So. Routine upward and visit the human one.
So you remember in the clear energy it's a peak, right? So in the decluster potential, we are supposed to have a plateau.
Let's see. The down door. Alright.
Like for this one, 41, right? We will take a value about here. So before it goes down.
Okay.
Yeah, kind of the highest one, but it's before it goes down. So we can select, for example, minus 40 maybe?
Yep.
Minus 40. And for this one, maybe minus 60. It's not very creative actually. Over left and right stance is okay. I'll allow you the plastic this value. Because this value is just to wait now. And then this may be also minus 60. Okay, so we actually has all the value. So we just write it down here.
Right. You cannot copy that.
We cannot copy it. Yeah, we cannot copy unfortunately. Later you'll see copy and paste is a big problem in this machine. So we use like a 41, 59.1. So sometimes the biggest matters, like 59.0, 0.1, the value can be something even few times difference. 11.5, okay.